We're going to build the soap bottle. It's a pretty basic one, a base and a cap. We will also take a look into how to create the nice sketches and refine them. And then when we're done, we will have also a design where the inside is cored out. Okay, let's make a new file. We want to make sure unit is set to millimeters. Let's go to front. All our snapping elements here are turned on. And we will start with a sketch. Click on this yellow plane. Very good. Middle mouse button, drag down. Then we will start with the line command. Okay, now we go to the center. Click, 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 and click, and escape. Cool. So there we now created a very basic sketch. Let's take a look at how we can manipulate the sketch. And this will be an introduction into how sketches inside a parametric model like Fusion work. So first, the sketch inside Fusion, same like with SolidWorks, is based on or works by a sketch solver. The solver adjusts how the sketch is behaving. This is very different to how lines and curves in a surface model like Rhino or in an illustration tool like Illustrator work. So what does this mean? Okay, with the mouse here, you see there's a point, a line, a fill. You can click this point and drag. Interestingly, this line actually follows it. If I click this, I can drag this line up, this follows and this follows. I can go to here. Now, this point moves and the lines simply change. I can move this point, okay, but I can't really move this up and down. So what's going on here? Also, why is this blue? Why is this black? You will see here these interesting icons. Click them and then we delete them. And then you notice, oh, cool. You can actually move them all. And go to here, select this icon and delete it. Oh, look, there's no point. Oh, the sketch is open. The fill is gone. Okay, so now we totally destroyed the sketch. No, actually we didn't. We simply removed all the constraints. So this is a completely unconstrained and open sketch. This is utterly useless for Fusion. So now we have to do it the correct way. And obviously we did this on purpose because this will be a really good way to explain to you what all these magical icons here are. So these are the sketch constraints. Constraints mean I can make a line horizontal or vertical. 2 points glued together. A line to an arc be tangent. 2 lines be equal. 2 lines be parallel. A line being perpendicular on another line. So I think at this point you start realizing that these are, we could say, geometrical restrictions. And the software then helps me when I move elements to keep everything else in check. So for example, when I move this point, these lines move. When I move this point doesn't move because these 2 points are glued. So to glue these two together, let's go to coincident, click, click, and you see now they're moved together. I would like this to be vertically constrained. Constraints, vertical, click. This I would like to be horizontal, click, horizontal, click, vertical, click. And the software understands if the line is more vertical, then it's vertical. If the line is more horizontal, then properly we guess, the software will guess we want this to be horizontal. So this is vertical, good, undo this piece. And now The software will think this will be more horizontal, but I want this to be vertical. So you see the software guessed incorrectly. This has to be more vertical. Cool. Okay, escape. Now, when I move this point, you see I can move this point up, but this moves up and then this moves left and right. It doesn't rotate anymore. So that's kind of like, in a nutshell, as a quick introduction, what sketch constraints are doing. These are like rules how all the elements can behave. So the proportions are pretty okay. We have a black line, that means these two lines are kind of constrained. We have blue lines, that means they can really move a lot, and we have the fill. Now, how do we get the sketch into the correct scale? Well, we add scale constraints or dimensions, not scale constraints, dimension constraints. So here, sketch dimension. This also literally in every CAD program the same. That's a cool aspect of teaching Fusion. Show you later use SolidWorks, Pro E, or whatever. The process and the concept is pretty much the same. The interface, logically not, but that's the minor part. So this I would like, click, click, to be 152 millimeters. This line, click, click, I would like to be 30 millimeters. This is kind of garbage here, no problem, we will fix this. That will be 17.5. Zack, there it's back. And then here, if I click on this line, you see I can do an aligned constraint. Or if I move my mouse to here, it's just based on the mouse position, I can do a vertical constraint. That is what I want, 2 millimeters. And this I would like to be 140. Very good. Escape. Let's delete this dimension constraint. Go back to sketch dimension, click these two lines. Look at that. We can actually add also an angle. So maybe 99 degrees. Cool. Okay. It's fair to say that at this point now we have a very basic sketch. So maybe we can take a look at how would this work as a model. Finish sketch. And here are our modeling tools. We have solid and surface. They pretty much are the same for most cases. Solid just creates a volume, and surface tools only create a surface. We'll go more into detail with that with other videos, obviously. Shift middle mouse button, go to this view, or we can also click and drag here. Now go to Revolve. This is selected. Axis, this one. And there's our body. Here's a slider. We can specify how many degrees of rotation we would like. So we want 360. Cool. Now we have a solid object. There's our sketch. There's our body. Down here you see there are two icons. This is actually the sketch and this is the revolve command. So this is the timeline. The timeline captures all the steps we are doing. So we could, for example, at this point now think, well, how would this look like if we core this out? Good, select the top face, go to modify and shell, drag the slider, very gentle, or type in 2. Okay, you see now there's an additional feature. I would like to look inside. Inspect, section analysis, click on this yellow plane. Okay, shift middle mouse button. There we are. Pretty cool. It's shelled. Now, The nice thing about that highline is it tells us how the design evolved, and we can move and change the order. And what's very important about CAD, and this is something we will learn in this model exercise already, is the proper flow. When do we do what? Now, all these modeling commands are pretty much based on tools we have in the wood shop or model making shop. The Revolve is a lathe. Extrude, well, it's kind of like extruding. The fillet is more like sandpaper or router. Split command, something like a knife, saw. The combine is like if we glue pieces together, or cut, etc. Draft if we rotate something or bend it, and so forth. And in the model making process, obviously we follow a very strict process. So we would make this bottle and then we would carve it out. And we wouldn't try to, how could I say that? Build individual pieces and then we glue it together. And what I'm trying to talk about is that in CAD, you want to start with very basic steps and explore proportions first. So that's what we did here. Basic sketch, this revolve, and then we quickly shelled it to see, does it work? And then step by step, we start adding details for it. So we can actually make something bad. So now I'm going to round this edge. Go to here, round this, and you see how this gets really thin till, yeah, this happens. And the software does it for us. It's just garbage, pure garbage, doesn't work. Double click. We could also say, okay, class just doesn't want two pieces, but what about this? Yeah, well, this is a thin area, this will break there. Now, check this out. This is actually the cool part about the timeline. So we did actually our command in the incorrect order. We should sketch, revolve, then we fillet, and then we shell. So the fillet, I think I can click and drag in front of there. Boom, check this out. Instead of a sharp corner, we now have an interior rounded edge. Amazing, no? Yeah, I think so too. Okay, so we would like to add a little bit more detail to the bottom part. So we can now go back to the first sketch. And zoom in here, create arc 3-point, click, click, click. I do this on purpose, really crazy, and finish. Nothing happened. And that is okay. Fusion is pretty smart. We just added something to the sketch, and Fusion understood that we still want to revolve everything what we have. Double click. There you see now this says two profiles, 1, 2. There are two ways now to change this. On a PC, it's Control or Alt Option, I think. You have to try this out. And on a Mac, it's the Command or Apple key. So hold the key, click, deselect the field, release the key. There we are. Now this is a totally silly bottom dome. Alternatively, we can also turn this selection off for the profile by clicking on this X, click again, there. And now you see how the software recalculated everything. Welcome to interactive parametric modeling. That's what parametric modeling means. We design something based on parameters, and then the software recalculates everything for us. So this dome is not really working. Let's go back to the sketch. Front. This will be very good to tell you what the tangent constraint is for. So right at the end here, I will draw a horizontal line. Now I will go tangent and say this arc flow tangent into this line. You see now? Beautiful. There. nice, nice and smooth, like a dome. We can bring this to here. No. Dimension, you, and 5. That should be 3. Very good. Perfect. Yeah, much, much better. No, the shelling is actually way too early. So I have to go back to here. And now at this point, I will start adding more fillet commands. So fillet, I would like this to be constant. And we set this to 4 millimeters. Very good. Yeah, this is better. Now here I have a 1 millimeter area and then this stuff arcs. So I will go to here, right click and say show dimension. Oh, look at that. Outside the sketch, I can add or manipulate the sketch. Now I could add another fillet there. 2 millimeter. Very good. Okay. So constant or chord length, where is the difference? So you see this is 2 millimeter constant. Let's go to chord length. You see 2 millimeters there looks very different. It's a little bit more advanced, but let me break this down the following way. With constant, the diameter of a fillet might visually change, and with chord length, the diameter will never change. Okay. Let's go to see where we can do a little bit more. Here we can fillet this a tick there. 1 millimeter only. That's good. Okay, so now when we drag this back to there, all is peachy. That's pretty good. Yeah, so the bottle is done now. Now what we could do is actually add the cap. So we will add a next sketch because we're adding a new object. Also on this plane, I would like this to turn off, and I would like to be able to make a reference to my existing sketch. Go to create, project, and then this point we project in. So what does project mean? You see how we copy that point in and it's magenta. That means if this actually changes, you see how that point moves. So we created a relationship between these two sketches. Now I will actually do something very quick on purpose so you can see how it doesn't matter how we sketch something. There's just horizontal constraint. Also here equal, that's pretty cool. These lines equal. 1 millimeter. Zack, you see this line is equal this line. I only need to dimension this one. Fantastic. This point I would like to be vertically constrained to there. Well, that's how we can do this. But nope, not that way. We need to move this further over. There. Distance, 1/2 and 1/2 in millimeter. Okay. U, 0.5. U, also 0.5. Look, I can click on this dimension too. So I made actually a reference. You see it says fx 0.1 because this is this value. Dimension 20. This is dimension 21 and this is dimension 20. This is dimension 19. Very good. This should be 10.5. Okay. This here, we can actually also override. We keep this at 1. And this we keep at 0. Actually, 0 doesn't work. 0.5. Technically speaking, when we thread the cap on it, this will be squeezed together or shut. So this needs to be wider because the threading has to fit in here, and this will be more tight. I, technically speaking, would draw this along this line. I'm simply in this exercise, keep there a gap, because I'm primarily at this point showing you how the sketch engine actually works with few modifications. Very good. Okay, so now shift middle mouse button outside the sketch, revolve, click this. Oh, a warning. No problem. You see here, this is hidden. So the object is there. It's just not visible. Okay. There we are. Maybe 1 millimeter for the cap is not big enough. So right click, show dimension. Here's my dimension for the thickness 2. Now this one is equal. Now this is much better. And this one now I could round with 1 millimeter, maybe 2. Okay. Very good. Very nice. We built our first very basic object, learned how to create 2 different sketches, got introduction into the sketch constraints, and then work with the revolve command, fillet command, shell command, and also the section analysis. And you see actually, hopefully, how logical actually the modeling process is, and how the timeline allows us also to shift steps forward and backwards in most cases. Okay, that's it.